So today's lecture, I'm going to cover head injury mechanisms and neck injury mechanisms in detail. What is that we are going to see is what are the various injury mechanisms associated with that. So for example, head injury mechanism, if you look at, you see there is something called brain injury mechanism. So the brain is an important part of human, and that's placed in the head very securely inside the skull. So even though it's securely inside the skull, during collision, especially in rollover collision, you see there can be an impact that can come on your head, and that can cause a brain injury. So what is that force that get in, and what is that mechanism of injury? So if I say tire rod interaction is an important mechanism for vehicle vibration and noise. So there is meaning that you immediately get it. So as that is interacting with the road surface, there is an undulation that energy comes with the broad spectrum of energy, and that energy is getting structurally through the cabin, and there the cabin has been vibrating and created unwanted noises at the lower frequency. That is what you say is a mechanism. So when you say like that, when you look at this in the context of biomechanics and those injuries involved, if I say head injury mechanism, the brain injury mechanism, how the brain get injured, what type of injury, and how is it being done. So there are mechanical parameters that are going to be understood there. So that is how we are going to look at the head injury mechanism and neck injury mechanisms listed here in detail. And then in the next lecture, we will see the rest of them. That is how we will end with our module 6. And then we look at an important aspect that I conclude in today's lecture. Maybe that is the conclusion for the next lecture as well, to complete these injury mechanisms, to take on with the 7th module, to know more about anthropometric test devices. ATD they are called. They are nothing but human dummies. So with that background, let's again get into the next slide. We're going to look at some anatomical aspects of our study. That's not moving. So what is that? The reference for this particular topic is the textbook, what we follow, recommended in our syllabus copy, compiled by Priya Prasad and journal Belwafa editors, of compiling many of the papers organized way for catering into 7 chapters. So we have already looked at the chapter for module 3 from there, that's chapter number 7, and we have referred for some of the time our textbook. And today's particular module is going to be referring to the chapter number 6 in this textbook, given by Injury Biomechanics from Head to Foot, Albert I. King. So this is the author have contributed towards the compilation of this matter, and this is what is our reference material for this topic. When you look at biomechanics of impact injury, there are 4 main objectives that go in. What are those 4 main objectives? Identification and explanation of injury mechanisms. So we should first understand what is the cause of the injury. That is what is identification and explanation of injury mechanisms. So how can we do that? It can be done by various tests and analysis to determine the mechanical parameters involved in causing this certain type of injury, that particular type of injury. So identification and explanation of injury mechanism through different tests and analysis is what is the first aim of biomechanics of impact injury studies. And the second objective or aim is to quantification of mechanical responses of various body regions. So it's all about interaction of driver occupant with the vehicle during the collision. So how the mechanical response of the body regions are quantified is what is the next aspect of this study. So it's right from head, neck, thorax, abdomen, pelvis, spinal, and lower extremities and upper extremities, all for the impact during the collision. Third objective is if we are good at identifying and able to quantify the mechanical response, you can come out with a determination of human tolerance levels to impact. If these three are very clear, that assist in the fourth objective to meet in this subject of biomechanics is assessment of safety devices and techniques to evaluate prevention system. So there are many prevention systems. So when you say prevention system, what is to come in your mind? It has to come in your mind as active safety systems that are something preventing it. So the assessment of active safety systems again depends on the biomechanics understanding of the prior three objectives, and that is where we could see in this era the development of biofidelity surrogates. Those are nothing but test dummies or anthropomorphic test devices. So these devices all developed. On the other hand, the computational facilities all are because of the four main objectives of this study of biomechanics of impact injury. So every time then coming to the first objective, identification and explanation of injury mechanisms. So what does that mean? So if you say injury mechanism, it is not one unique mechanism that is there. It is as it is for a structure. If you say vibration noise in a vehicle, there is not one unique source that causes. There are many sources and there are many ways that energy get transferred, and they are classified into structurally transferred energy or through air transferred energy. That's how we look at it. Right? And similarly, if you look at here, there are many mechanisms, but there cannot be one unique mechanism for any injury. That's a complexity level of identifying an injury mechanism. So, of course, there are some examples that I have just written down here. Those are a failure of long bones occur, that is pelvic bone, if you look at that, occurs as a result of tensile load being applied to it. In most cases, the tension would come from the bending of the bone. So when you see any structure is bending, you see there are layers under tension, the layer under compression. So the tension comes because of bending of long bones, and that is what is caused because of application of bending moment. So there are bending moments that act on a human occupant during the collision. If you look at another hand, very sensitive injury called diffuse axonal injury, DAI called, as a result of angular as well as linear acceleration of the head. So during crash event, the crash pulse is what is getting into the occupant, and that crash pulse is responsible for creating various parts of our human to getting subjected to vulnerable acceleration, decelerations, and so on. So at the head, center of gravity of the head, the angular as well as linear acceleration is going to be realized, and that is what is the main cause for this DAI. In that case, the injury mechanism of DAI is not unique again. It's not unique. However, both of these motion, that is angular acceleration, motion due to rotation, motion, translation, can cause what is called shear stresses to develop in the brain, and thus the injury mechanism can very well be said as shear stress or strain in your brain is what is going to cause this DAI. So we have again in detail another injury associated with the brain in our upcoming slides. However, I just have put these two as an example for how complex or what is that we talk on an important objective of identification and explanation of injury mechanism. Of injury mechanisms, right? So Coming to the second objective of the study is quantification of mechanical response. In engineering side, we know that the standard procedure of classifying a material is to define its mechanical response to the applied load. So we do conduct the test called simple tension test or compression test in UTM to characterize the material through its mechanical properties. The same can be done on biological materials as well for bones, and we can apply a comprehensive load and obtain its force displacement response. Similarly, for the ligaments, we can apply tensile load and obtain the same responses. So there are people working on biomechanics side. They work on estimating the strength aspects of human bones and tissues and so on. Those details may be very much essential as we go in for creating virtual human dummies in mathematical era in finite element models. So, however, for some complex body regions such as chest, we need to load it in different directions. So, for bone, doing bending test is easier. For tissues, doing biaxial tension test is easier. But in the case of organs like chest, organs inside chest, no, it is not so easy to conduct such tests because the load can be from different locations, and locations to obtain its response in frontal and lateral loads of upper, mid, and lower thorax. So thorax is what is this region? Below the neck and above the abdomen, whatever region is there, that's called the thorax. For organs that are within the body, the task is more challenging, especially if you want to test it in situ. So test it in situ means it is in real-time testing. So we can't test with the human volunteers for such tests. So the cadavers are used for finding out the mechanical responses. Also, you see, there are no tests even with the cadavers of childs or children because of the ethical practice. Elderly cadavers are tested, and then the data have been inferred for the child occupant as well. Right, then accurate quantification of brain motion inside the skull due to blunt impact was not achieved until beginning of the century. That means now it's possible to find out so clearly this thing, the mechanism. So that's what we are going to look at in today's class in detail. However, we were just discussing on the second objective now. The third objective is what is called tolerance level due to impact. So how do you go about doing it? Every time I have to come out of this. So quantification of mechanical responses is the third objective. What is that? I have here these two pictures. So one is for brain motion due to blunt impact. Another one is thorax response for the frontal impact. So thorax means there are ribs around our chest, thorax region. What are their displacement? So we have seen that we have the accelerometer at the head of the dummy centroid location, and also we look at a load cell at the thorax region in the dummy. So the mechanical response can take many forms. The traditional engineering approach is defined the response in terms of stress versus strain, or load versus deflection. However, the dynamic response, we can define force time response or displacement time response. So how fast, the velocity of individual organs, all can be the responses that can be quantifying this injuries. So you can see in this brain motion due to blunt impact, you can see there are many spots with the 8 symbol. So that means there are a particular point in the brain is being traced its motion with reference to the CG location of the head. So see their motions. So that is what is predicted through the scan. And you see on the other hand, there are impactor on the response on the ribs and the displacements in this graph. And here you could see they are represented as function of force, and force is function of deflection. So this is all something that kind of detailed mechanical responses people do carry out and get, and sample of them is what is shown here in this slide. And continuing with this, this is not changing. Then coming to the third objective is this determination of human tolerance level to impact. So in the design of safety systems, the vehicles of any kind, it is necessary to know how much acceleration or a force the body or the part of body can take before the serious injury is incurred. This is a study of human tolerance to impact. So the perennial question, if I ask, how many G's can I take? The answer is another question. How badly do you want to get hurt? So for a question, the answer is another question. So that is the kind of way we look at the severity. So why this question, answer to the question is because that is going to give the clarity of the scale of that defines the severity. So there are several levels of injury, and safety and the safety design can focus on one of those levels for a given impact severity. So the injury levels are given by the scale 1, 2, 3, 4, 5, 6, and they are called abbreviated injury scale, injury scales. So when I say 1, that's called an ouch level. What do you mean by that is that doesn't have any problem. That's not going to give any pain. So normally there are volunteers, women are tested for how they are pursued with their vibration and so on. Some kind of human machine interaction test. If you look at that, volunteer is not having any pain, comfortable. That is what is called an ouch level. There's nothing, it's normal. In case he feels some kind of pain, that means it's transferring from level 1 to 2. That's called a minor injury. That's where the volunteer can come out of the test and then stop and then go. So the ouch level is something that it's comfort and nothing to worry. There is no injury. There is nothing to worry about. The 6th scale, of course, there is no chance of fatality. So that's safe level. And then you see there are level minor injury, moderate injury. So this minor and moderate injury are given with 2 and 3 levels, severity level. So they are not that to be worried regarding even to the hospitalization. You may have to go for an emergency ward, but you don't require to be hospitalized for prolonged duration. That means that may not involve with any fracture and so on. It's a small scratches or small sprain and so on. So you require, of course, the medical attention, but that doesn't require you to have a prolonged treatment in hospitalization. And then serious injury. Serious injury is something is that's taking a threshold, you can say, from this region to this region. So serious injury is something where it is there are chances of fatality. So you require hospitalization for longer duration and attention to be given. That kind of warning. But critical injury is something that is likely to get fatal injury, that likely to lead to the death. So this is so critical. That's why it's called. That is the scale 5. And scale 6 is what is fatal injury, where the collision cannot save the life, and then it is 100% assured death. So that's what does this scale refer to. And if you understand the injuries connecting to this severity level, they are called AIS, abbreviated injury scale, 1, 2, 3, 4, 5, 6, like that. So you can see here an example of thoracic brain injury. That's because of angular acceleration, rotational acceleration. So there are 50% chances of probability. So this graph says what it is: injury probability as function of rotational acceleration, measured in the head with the help of an accelerometer in the test. So this angular acceleration level of 5,500 radians per second would create a chance of 50% injury probability. and that injury is what is called traumatic brain injury. So this is a kind of severity level that you could see. So if we have to go for this severity, brain injury can be in a serious or critical injury state. It can be. So that probability is 50% if your angular acceleration measured in the test goes up to 5,500 radians per second squared. So it has to be in smaller values. So you could see here there are 53 test reports. Out of that, 22 injury and 31 non-injury are reported. So non-injury means maybe it is lower than 50%, and injury means it's more than 50%. And this function is something called the power probability density function in mathematics of random vibration. You would have studied. Right. So this is how one can understand that human tolerance level to the impact with reference to classifying the severity in terms of injury level. So having these three knowledge of knowing the mechanism, identifying and evaluating the mechanism, and then finding out the mechanical response in various mechanisms, and with a full awareness of what is this human tolerance level, one can easily get into venturing to make an assessment of safety devices and techniques. So the knowledge gained in the three areas that we discussed so far in previous slides can be used to assess safety devices in vehicle and other systems. The two principal tools are the crash dummy, hybrid 3 dummy is being shown here for your reference, and computer models. For the last half century, most of the assessment has been experimental using the crash dummy. This assessment is made as the design is progressing and calls for many crash tests, that are costly and time consuming. The automotive industry has begun to realize the computer models are now sufficiently reliable to be used as an assessment tool. With the aid of models, the designer can skip much of the crash testing, real-time crash testing, and do the final test of the system at the end of the development process. There is now a consortium in US they funded for developing a single total human body model that can be used in place of hybrid 3 dummies. So this so the hybrid 3 dummy though they are replicating the human and they are able to accommodate the necessary sensors, and they can be nicely placed in concurrent with vehicle ergonomic aspects of inboard, outboard. Still, real human as a dummy is under the research, and there is a consortium that's working on it. I think we have seen one such human dummy, which is more realistic to human in 2020, and one of our lecture in the beginning lecture when you talk on the introductory lecture, I mentioned it. Please go through it. And coming back to now our topic of understanding injury mechanism, today we are going to discuss on two injuries, the head injury and neck injury. So let's first understand some anatomy of this brain. Then it is easier to follow what are we doing it in the class. So in our school days, if you are all taken biology, you could have studied. Let's just revisit what it is. So you can see this spinal that is there holding this brain, right? So spinal cord, and that is where at the top you see this brain, and the brain is secured inside nicely from the skull. The skull is not shown here, and if you look at the centermost part of your brain is what is called corpus callosum. See, the pronunciation is very difficult, and pardon for that, and it's all medical terms we are not very much familiar, right? And then another important part here is inside corpus we see the most core part of our brain is thalamus. Then we have this optic suchasma. Optic suchasma is there here, and then we have hypothalamus. Hypothalamus is what is this part of the brain. And pituitary gland, you know why it is very important. The pituitary glands are these are some surapihal in Tamil we say. So very important in our body that have a harmony of our living. If any gland is not working properly, then we will be having many issues. That is all we know that. So the pituitary gland is just at the bottom of this brain here, and then you see there is not able to read it. It's so small. So mammillary body is what is this, and then you see bones. It's not bones. There's bones here, and then medulla oblongata is what is this, and that's where you start your spinal cord. Spinal cord is protected with the spine bones. So that we will see that in the neck injury time, the anatomy. So that is how it comes. And this side, if you look at the brain at the bottom, we have cerebellum. So that's very important. Cerebellum fluid is there around this brain. And then we have our brain has got a frontal lobe and parietal lobe and occipital. Occipital lobe. Occipital lobe is something we will come across in our neck injury and head injury when we are looking at it, right? So this is there. So if you look at, there is a portion, temporal lobe is what is taken out to see this inner detail where you could see limbic lobe. Limbic lobe. So this is how you have different parts of your brain. And of course, there are many veins and arteries to take blood and then drain blood from brain. You have veins and so on. Those details are not there here. There are nerves. Those all are not there. So just it is making what part is what in the brain. And the same is there on this side as well with the background, the shaded face, and where is the location of our brain? It's the top. That's why sometimes it's called atlas, right? So with this basic understanding of anatomy of brain, we are going to look at now an important head injury called ASDH. ASDH. So what is ASDH? It is acute subdural hematoma. That's because of bridging vein rupture. There are veins. So veins and artery that we know. Vein is draining the blood from organs, and artery is pumping the blood from heart to any organs. So this is the function of vein here. So now the vein rupture is what is going to make blood clot. That's what we say. When accident, you see there is a blood clot bleeding inside, then the person is undergoing unconscious and so on. So that is what is called a ASDH, called acute subdural hematoma. So what causes this acute subdural hematoma? So let's look at this anatomy of this sectional view of our brain. So you see that skull is there on top protecting, and then dura. So you know what is dura? Dura is what is the first contact with the skull, or the topmost layer of your brain. And then the superior sagittal sinus. There are many sinus like that. Sinus is something, it's a pool here where you will see the fluid. And this is what is called here veins. So the veins, they're draining the blood. So there is a rupture here, there is a blood clot. And this location is what is called acute subdural hematoma. So you see now the layer dura, and then the layer, after that the layer comes. Yellow in color is dura, and then next is dural border cell layer, next layer. And then we have third layer that is called arachnoid border cell layer, arachnoid. And then inside the arachnoid. So arachnoid border cell layer and dura border cell layer is what is this middle. And arachnoid is what is that the fourth layer inside the skull. And that is what is going to interact with this blue color region, what is called a fluid, that's called the cerebral spine fluid, CSF layer. And there is something trabecule. Trabecule is that structure. How does it come? That's kind of viscous medium there. So that's kind of acting a cushion between this protected cover skull and then many layers, and then we have this kind of fluid, and inside then we have your complete brain. See how nicely the brain is protected, right? And in this, we are looking at this bridging vein rupture, and that's what is causing ASDH. So, what is the mechanism that behind in this ASDH? That is what is there here. So, there are positive pressure and negative pressure, and shear due to pressure gradient or relative motion of the brain with respect to the skull, right? So, this fluid, this CSF fluid is there. So because of that, the movement of your brain relative to the skull, you can have the positive or negative pressure created. So when this kind of movement will come, it is not all the time. It is kind of floating inside the brain, hardly less than a kg part. It's kind of nicely been secured inside our skull in the CSF. But the movement is not so vulnerable. So when it will be when there is a hit. So that's what is that at the site of impact or the coop site. Coop site is where you get an impact. So if I get an impact like that, or if I get an impact anywhere on my head and the skull, then that point is what is called the scoop site. A positive pressure or compressive stress is developed immediately inside. Developed, and a negative pressure occurs at the, so positive pressure at the impact side. Exactly opposite is what is called the counter coop site. Counter coop site. There you get a negative pressure. So there is positive pressure, there is negative pressure, and these pressures are accentuated by the deformation of the skull, in bending of the coop side and outbending of the inbending of the coop side and outbending of the counter coop side. So there is an inbending, there is an outbending. So that creates a kind of a movement, and that movement is what is measured through an angular acceleration and a linear acceleration. So the positive pressure can contuse the brain, while the mechanism of injury for negative pressure can be due to either tensile loading or cavitation, which is compressive loading due to the collapse of vapor bubbles. So we know what is cavitation process in particularly turbines. All you see the cavitation effect. So the vapor bubble formation, bursting, that can cause damage to steel structures on the wheels of your turbines. So if you look at like that, there are cavitation effect here. That is what is the rupturing and then bursting of veins. So that kind of cavitation in this CFS fluid can also be caused due to the compressive loading due to this positive pressure. Negative loading on the other side, right? The vapor bubbles formed as a result of negative pressure. So negative pressure would create such kind of vapor bubbles, and that get compressed, that get burst. That cavitation effect is also the reason why you have this ASDH, the clotting that happens. Suddenly your veins get ruptured. So the draining process of your blood is affected, and then the clot may stop it, and that is the reason why you get some disorders. You get immediately unconscious and so on. So this is the kind of mechanism that go into head injury. So let's look at now neck injury mechanism. So anatomy of the spine is what is very important. So because the neck is what is this portion, that's top of your spine. So what is that spine anatomy? You see cervical. So cervical is what is that first on the top. So you get this C1, that is what is attached to your cerebellum of your brain. So you see the spinal cord that goes into brain. So that's going inside this. So that spinal cord is well protected by these kind of bows. So now these bows are very special bows, and they are called by the name. What are those called? I'll just say in a minute. And the next slide is there. So you see this disc here connected nicely. They are called C series, T series, and then L series. So C1 to C7, there are 7 elements. That's called cervical disc. cervical area. So that's very sensitive. Our neck is cervical actually. Our neck freedom is because of the cervical movement. And then you see thorax. Thorax is our neck till abdomen, this back spine. So we are able to have this freedom all is because of thorax. So every disc will have a ligament, disc between ligament that gives you this kind of freedom. So we have thorax disc are the elements T1 to T12 of them. And then we have lumbar. So the lower part of our spine is what is called lumbar. Upper part is what is called cervical. The middle portion importantly called thorax. And then you see the lumbar ends with the L5, L1 to L5, and then it's connecting to sacrum. And then at the end you see coccyx. So these are all some of the anatomical naming of our spine. If we have understood that, now these statements could be easily followed. So the neck injuries can vary from mild injury to catastrophic. So the fracture of this all happens, that is all. If you get this is detached from your cerebrum or from your atlas, that is from your head, that's all over. That is fatality. So that is what is catastrophic. Mild means you get pain. It's not only due to muscle. There can be some smaller dislocation or something that may take months together hospitalization also. So small impact on that, we get strain. Sometimes we're sitting for longer time and preparing, delivering lecture for longer time, looking at monitor. So that all can give kind of strain or pain in our cervical or thoracic element. So when you drive more time on our vehicle, you may get pain in lumbar. So you get back pain and the lower spine. So this is all something a mild symptom of the injury. So neck injuries only if you look at that's confining to this portion. Only cervical injuries are called neck injuries. Thoracic injuries are separately we look at. Abdomen injuries we'll look at, and then lumbar all we'll see after that, right? So today's neck injury mechanism, when you say it is all confining to cervical injury, that's related to C1 to C7. So C1, C2 are very, very vulnerable. That's very, very sensitive portion that get affected. So generally the injuries involving the spinal cord at the higher cervical level are life-threatening, while those at the lower levels can lead to result in paralysis. So that is also life-threatening. Life-threatening means here it is fatality. Paralysis means you get paralyzed. So that's what this cervical discs of our spinal are very, very delicate, and they are nicely sitting here, and God has gracefully given such a wonderful mechanism. And to injure the cord, so we don't intentionally injure it. If you feel that this injury your spinal cord, it is necessary to disrupt the alignment of or integrity of the cervical column. So this alignment and integrity of cervical column is not easy to dislocate. You have to give such a force, then only it can. So unless and until such kind of mechanical forces or moments that are acting on it, it won't happen. Nothing will happen to it, right? So that is what this statement refers to. So burst fracture of cervical vertebral. So this is what I was telling. Vertebral is what is these all elements. Vertebrals bodies can propel fragments into the cord and can cause permanent cord damage. So it can be fracture here in this, and that can be a permanent damage. That you can see the people with the belt around the neck. So all the time they have to be like that. It's all because of there can be some injury or fracture, hair crack in this any one of the C1 to C7. So they cannot even have a slightest movement. So that's but that comes under the mild category, right? Because it's not catastrophic. So this is what is the anatomical aspect of our spine, and then injury level. Upper cervical, that is C1, C2 are affected, life-threatening. Lower cervical zone can lead to paralysis. That's a take from this slide. Now, we have a few more slides only, we'll finish it. Neck injury mechanisms looking at now, look at now, that's what is that an assessment of three aspects. We understood the anatomy, the mechanism of injury, and then the response, what it could be is understood, then the severity level is understood. We could develop such kind of dummies. And this dummy is a virtual dummy. This is an Abacus software really available module dummy, and that replicate the entire spinal. So you have this occipital interface. Occipital interface is that connects to the atlas, that is the brain, to this cervical C1, and then C1 to C7. There are 7 items here, and then thoracic T1 to cervical. The C word is cervical, and T word is thoracic, and lumbar L word. That's how you can remember. So this is that model, and you could see the sensitive places, the sensors, and the coordinate system, and so on for the measurement. Okay, this I put this picture is that we will have this in hand in vision when you look at the statements here to understand neck injury mechanism. If the cord is impacted, the cord here is spinal cord is impacted or crushed temporarily, sufficient damage can be done to paralyze the extremities. In the upper cervical area, separation of atlas from the occiput. So occiput is what is this occipital interface. So this zone is called the occiput. So that separation is generally a fatal injury. So high injury, a rollover, the person get upside down, and his head is being constrained by the roof, and the entire load of the body comes on the head. That's a kind of big crushing. And that crushing force can damage or can be sometimes frontal collision. You see there will be a shear stress that is coming that can shear off this portion from the atlas. That's what is fatal injury. So that breakage at this point is fatal injury. Other life-threatening injuries to the upper column are multiple fractures in arches of C1 and fractures through the pars interarticularis. So again, if you go to anatomy of this disc individually, you will understand what are these terms. So in C1, C2 fracture is again another life-threatening aspect. So critical. Immediate death is breaking, and then even injury at C1, C2 level is life-threatening. Milder form of cervical injury include so-called Whiplash Syndrome. So people all work, and we looked at in the video, that's a big business, $1 million business. It's all because of this Whiplash Syndrome. So Whiplash Syndrome itself is an injury that we will have prolonged pain if we are neglecting it, and that would be caused slight rear impact of the vehicle on the vehicle, right, from rear. So that Whiplash syndrome is what is that in our scale is called a milder form of cervical injury. So for that itself, the restraint system like a headrest or head restraint systems are now focused. So see that this type of fatality related to neck injury, what kind of protection systems are there? Only active safety system which can prevent the accident. So neck injury mechanisms. So neck injury mechanisms we will look at as we look at the fact that the spinal column is slender in nature, which can be subjected to variety of bending loads associated with an axial load. So it is a combined load. It will bend as well as it will have an axial load along the spine. The injury mode can be classified because of that as follows. It can be under compression, tension, and extension. Tension itself is like that, and further extension. And then tension, flexion. Flexion means bending. And then compression, extension, compression, flexion, and lateral bending. So lateral bending is something like that, right? So if I do it like that, my cervical is under tension. If I put a load, take a big bag of cement, people are working and they keep it on the head and walk. See, the cervical is under much compression. See how tough people are carrying load. No, they are tuned to that. So they develop the strength of the muscles so that the muscles will carry the load and the cervical would be safely protected. But suddenly and we go and take it and keep it on our head, it will be loading on our head, and that can go for compression, complete compression. So these are all the various modes that are associated. That is how we can able to get our mechanical response of this, and then we can put them in which category of tolerance of severity. And then neck injury mechanisms. Let us look at one by one and then finish our lecture. So compression injuries, if you look at, you have here at the bottom, there are pictures associated with that. You can please go through it. So these injuries result from crown impact to the head, which produces a high compressive load on the neck, accompanied by bending load, which can depend on the initial orientation of the head. So what is the initial orientation of the head is important. So if I have it like that, it's different, then it won't be compression. It will be bending as well as compression. If I have my head straight, then the load comes, then it is only compression. So initial orientation of the neck and the surface friction. So they are not common automotive injuries, but can occur in ejection on rollovers. So this may not be a common injuries because our vehicles are equipped with the safety system. We do not get such kind of fatal injury that we discussed that can happen in the neck. That's all the facility of safety system. But when can happen? It can happen in rollover crashes. That people are ejected out of the vehicle. At that time, this kind of injury can happen. But we have seen in one of the videos in rollover also people have escaped. That is all because of God's grace and the vehicle design promptly help them to get ejected safely out. So these are all the facts. The compression comes, compression comes from the mass of the body following the head. So when rollover case, your head is on the roof and you are upside down, your entire body load comes on your head. So that's where you get such kind of compression injury, which is stopped by the restricting surface. That's the roof itself, right? So this is something that we say what is compression injuries, and tension extension injuries. That's what is Whiplash syndrome. Is frequently associated with the type of injury. It is generally assumed that the injury is a result of hyperextension of the neck, which is also apparently in tension as the neck is stretched out over the headrest and seat back. However, cervical spine is initially placed in compression by the seat back, pushing on a hypotic thorax spine back. As the thorax spine it pushes up, and the cervical spine, the thorax spine tends to. That means you see the thorax spine is now is kind of arch here, right? So this is kind of an arch now. So if this becomes straight, what will happen? This portion would compress this cervical portion, as this portion will compress this lumbar portion. That's what is given here. As the thorax spine tends to it pushes up the cervical spine and down the lumbar spine, applying a compressive load on both spines in the process. So both sides it is going to give the compression. As a result, the ligaments and tendons holding the cervical spine together are loosened, while the vertebrae are required to transmit a large shear force from the torso to the head. So the torso to the head, you see that vertebral is to transmit the large shear load at that time. So continuing with that, tension flexion injury. So these are relatively uncommon because complaint of chronic or persistent neck pain by tilted occupant involved in frontal crashes are rare. In very severe frontal crashes, Atlanta occipital and the C2C2 separation can occur. That's a severe thing. These injuries can be resulted in fully restrained human subjected to a frontal deceleration of 120 Gs. This is one of the research publication. This value is given. At 120 G deceleration and frontal deceleration, this tension flexion injuries can happen. Then compression extension injuries. Compression extension injuries, again, look at this anatomy. You have what is this vertebral body? Vertebral body is this every spine. This is the portion where they get interlocked. So you can go through slowly. So here it is T is given. So thoracic spinal elements are there. This naming other thing you can go through because that's appearing in this statement. So these injuries used to occur to unrestrained front seat occupant. So if we are not restrained, this would be happening. Compression extension injuries can be because of unrestrained front seat occupants involved in the frontal crash. When the head impacts the windshield, we have seen in a video. So when sudden brakes are applied and impact, you are thrown to the windshield. The neck gets first hit on the windshield. So the neck is placed into extension. At that time, it's placed into extension and compression simultaneously. Then they are likely to sustain fracture of one or more spinous processes as well as symmetrical lesion and pedicles, facets, and laminae. So these are all various parts of this part. That's why I just have put this details here for you to follow what is this statement says. And compression flexion injuries, these injuries are similar to those earlier under compression injuries that you have seen. When the loading on the head causes the neck to go into flexion. The injuries include burst fracture and fracture dislocations. So you could see there are three modes here. What's happening here, you could see, right? The ligament get torn here completely. See, this is the ligament that get torn. So what would happen after that? So you see there is a rupture, so that's breaking. So this element is disconnected. So if something goes out of that series T1 to T12 or C1 to C7, that's going to be life-threatening. And then lateral bending injuries. So the lateral bending occurs when there is a side or oblique impact in your vehicle. This usually is accompanied by shear and axial loading. Lateral wedge fractures of the vertebral body and fractures to the posterior elements. So this vertebral body, posterior elements, all there in the previous slide. You can just see that. So the vertebral column or injuries characterized by this type of loading. So what is that particular type of loading is the lateral bending loading. So that means this way bending, lateral bending loading. The neck is also frequently subjected to twisting, but that's very rare chances. But you can make it. Say your kids are calling you from the rear seat and you are taking a turn, you get a twist on your neck. So that's what is twisting, which can cause unilateral facet dislocation. So facet is the part in this. You could see that facet is this portion. So you see there is facet. So facet is something this interior articular facet and superior articular process. So process means it is not some event. That part is called like that, right? So pedicle. This is vertebral body. So like that you are looking at it. So over which we have your tissues. Like that you have element after the element and the interlocking of this and so on. So you've understood that here, that's what we are talking on. This facet dislocation can happen. So that you can see here there is a dislocation. This moving, this move due to rotation. However, pure torsional load on the neck are rarely encountered in automobile crashes. During the crash, it is not happening because you stayed like that. But during the crash, you have an attention, what's happening to my child, you are inducing, then of course you get a twist also at the time. So this is all something anatomical aspects that we have looked at, maybe like a biological class, but it's mandatory to follow what are these injuries and their mechanisms. And this helps us to go in for understanding what type of measurements and instrumentation that are needed, what are the severity level with the AIS we have looked at, but you can also see that we are going to have every mechanism there is an index that we will see in our tomorrow's class morning 7:30 to 9. Also, let me just before concluding the lecture, let me just go through this paper submitted from our group students, Sobit Jain and Shivam Chawla. They have done a good work and they have nicely compiled this topic, and that is again assisting us to learn. So study of injury mechanisms and safety measures during vehicle collision is that J component topic. They are nicely written with that comments given yesterday, nicely rephrase this abstract. And then their aim in this paper is to look at motor vehicle collision in particular and the injury associated. So if you look at here, they have gathered this information of complication with injury mechanisms. There are many. It is not only with the motor vehicle collision. So motor vehicle collision zone is only this portion, only this portion. So you have here can be a respiratory problem. You can have here blue line that's called infection, and you have yellow one that is postoperative. You have gray line, it's more here, that's for cardiac. So there are some of the severe fatal injuries that can be witnessed. So they just have categorized from this figure what is that complication of injury mechanism. In particular, they come from where? So if the people are working with the machinery, these are very low level. They fall from huge building top of the kill bottom, then that's very severe injury. Like that, you have the different scenarios. What is the injury level, right? That's what is an whole perspective. They narrow down to motor vehicle collision study, and then you could see there whatever today we are discussing. They have gone through already injury mechanism, neck injury, head injury, and so on. And they had some interesting case study and where the rib fracture mechanism was studied and they reported in this paper. And again, you could see this injury data abbreviated, whatever that abbreviated injury scale that we have looked at based on that. So you look at head injury, if you see number of people tested, that is here it is severity, it is critical. The fatal, so fatal is very less. So total population fatal is very less. So like that, no, they are able to make it, and they looked at this in two colors, blue and red, orange. The blue is of slow offset impact and small offset impact, and another one is large offset. So if we have more offset, that's referred by yellow color here. So small offset causes a severe injury or critical injury and is causing a fatal. But more overlap injury, you do not have a data as there is any fatal reported. So it's a nice compilation and presentation of the data here, the case study they have done. And then they also explain here the movement of our spine. What are the freedoms, and then with respect to that, what type of force that come and so on. To understand, here it is the joint, revolute joint. You know what is it? This is ball revolute spherical joint, a cylindrical joint. That's why here you have one at the C1 location, occipital called, and then you have see at C7 after that. There is that. So that's what is cerebral completely that's taken here. And then you have here translational, that's in thorax. So thorax we have between those elements, you have the filaments. That's why you have this longitudinal freedom. And this is a total mass point of our joint. So that's nice diagram. They've taken it and explained in the study. And then see there are again largest injury producing load source in the body region. They have again taken the reference to steering wheel airbag with the restraint system. What are the load that comes and number of injuries? And again, the study focused on torso injury, that is in the upper chest part, with belt only, belt and side, and various parametric details. So they have taken a good paper and they studied, and then they have confining all with this respect to this injury, abbreviated injury scale. And then they have also done the aspects of vehicle safety system that go in preventing this kind of injuries that are there in the vehicle. So injury prevention. So nicely they've gone through, and then they concluded with some quantitative data observation from the details. These injury, what are the types of accelerometers that are used, and the values of injury level. So that's a good work from Sobit Jain and Shivam Chawla. I just wanted to say that during this lecture hour, it's very apt. With that note, I'm going to stop this lecture. If we have anything to discuss, we will have a discussion. Otherwise, we will end the lecture. Any discussion? Sobit Jain and Shivam Chawla, both of them are not there. The others are there. Yes, Chawla is there, Shivam Chawla. So good work, Chawla. Anyhow, we have to refine. There are many information that you can incorporate, and please do work on it. And then let me also revert back to that and modify and try to communicate to a journal. Right?
Yes, sure.
Yeah. So with that note, let me stop. This may be a long lecture, but we have done some quantum of portion completed in module 6, and tomorrow morning 2 periods, let's look at the remaining part. Also, let's look at what are the injury criterion and other aspects that lead to take on our ATD, anthropomorphic test devices, right? That is our module 7. So hopefully we'll be able to complete with an appropriate perspective, the outcome expected from the course mentioned at the beginning of the lecture. I'm very happy about today's lecture, is particularly I have brought in the whole sum of what we have learned so far. And then I connected, and then we have got a kind of revision at this hectic schedule. So you all got nicely oriented, as I was telling at the beginning of our semester. My role is to make an abundant material for this topic available as a version in internet and textbooks in an organized manner, categorizing, making notes and lectures, preparations. I spent entire this semester I was living with this Crashworthiness course alone and thinking of all of you, and I'm doing that, and hopefully I would hold this momentum till I finish this lecture. All lectures for the course and complete all formalities of conduct of exam, evaluation, and so on. So with that note, I'll stop